I'm going to write 3 and I'm going to write 2. 3 plus 2 is 5. So 3, 5, 2. It's a magic. It takes 1 second to do it. So how can you do that? So you write 4, you write 5. 4 plus 5 is 9. 495. It's as simple as that. Very simple. So it takes 1 second. You give me any number. I'll tell you. I don't know. 34 times 11 would be how much? You write 3. You write 4. 3 plus 4 is 7. 374. And we're gonna write 97 over here. We're gonna make a line. Okay. So how much 99 is away from 100? Negative 0.1. And how much 97 away from 100? Negative 0.3. So the Vedic mathematics tells us this is how you do that. 97 minus 0.1 is 96. And negative 1 times negative 0.1 times negative 0.3 is just 0.3. So 9603. Pretty simple. So 470 to 530 540. Number 2. Brahmagupta. So Brahmagupta 600 to 670. And Ramanujan. Indian contribution to mathematics. Number 1, 0. There was India invented 0. The most important concept. The most important concept is in mathematics is 0. And guess who? Guess who invented 0? India invented 0. And who invented 0? Aryabhat. So we're going to talk about Aryabhat in a second and why he invented 0. What led him to invent 0. And then the calculus. Calculus. And now when we talk about calculus, we think the calculus was invented by Sir Isaac Newton in 1665 and independently also created by Leibniz. No. Brahmagupta invented calculus a long time before Sir Isaac Newton and Leibniz. Alright, so we want to give the credit where credit is due. Number 3. Infinite series. Power series. Ramanujan is one of the pioneer of power series we're going to talk about in a second. Number 4. Trigonometry. India, one of the most important contribution to the body of mathematics by Indian mathematician is defining the sine and cosine, law of sine and cosine in trigonometry, making trigonometry a tools for astronomy to find the distance, for example, between sun and moon and the sun and the earth. So India really made trigonometry useful. Number 4, we're gonna skip that and we're gonna talk about Vedic mathematics. So Vedic math. Vedic math is known as a spiritual math in India, but it's a useful tool. Do you remember human computer? Who regarded as human computer? Shakuntala Devi. Because Shakuntala Devi was able to kind of multiply any big number by any big number using Vedic mathematics. So Shakuntala Devi is regarded as the human computer. She's Indian, of course. She is considered as the human computer. How did he manage to beat supercomputer? in 1984, there was a supercomputer, and there was Shakuntala Devi, and a group of professors gave her a problem 10 by 10 digit, and computer also 10 by 10 digit. Shakuntala Devi beat the computer. She solved the problem 10 seconds before the computer. And how did she able to do that? By using Vedic Mathematics, which kind of allow you to solve the math faster. So today I'm going to talk about, briefly I'm not going to talk about Shakuntala Devi because I don't regard her as big as Aryabhat, Brahmagupta and Ramanujan. She was able to do a whole lot of math, but you know, these are like Trinity. These are Trinity of Indian mathematics. Aryabhat, what did he do? He invented zero. There was no concept of zero. Not even the Africans who solved the math problem using Ishango bones had no understanding of zero. Mesopotamian, the people in Iraq who gave whole lot of concept to the body of mathematics but had no understanding of zero. Egyptian mathematician who gave lots of mathematics, who created lots of mathematics to build the pyramid for pharaohs, had no understanding of zero. Chinese mathematician who created a body of mathematics to do trade had also no understanding of zero. So the concept of zero really came from India, came from our home. We take lots of pride. Alright? So when you talk about mathematics, you really talk about Indian mathematics because India did a whole lot of things. I did not mention a lot of things like the base 10 really came from India, and base 2 as well. So I did not mention those because I mentioned only things that are very important. And then Brahmagupta, he created calculus. He created calculus, especially the differential calculus. We give credit to Sir Isaac Newton for creating calculus because he saw an apple fall 1665, and inspired by that apple fall, he looked at the sky, he saw moon, he wanted to solve falling apple, falling moon problem. This created calculus to lay the foundation of physics and use the calculus as a tool for physics. But this is true. But this is also true. Brahmagupta also created differential calculus long time before 1665. And that takes us to Ramanujan. And as you know, the Ramanujan lived only 32 years. So Ramanujan, in his lifetime, Ramanujan did a whole lot of things, including the power series. Okay? So if you mention like 5 mathematicians in the world, 5 top mathematicians in the world, you have to mention Ramanujan. For example, who is the number 1? Sir Isaac Newton. Who is the number 2? I don't know. Who could be the number 2? Number 2, Gauss. Number 3, Fermat. Number 4, I don't know, Banwali. Number 5, Ramanujan. You could place him even above Banwali and Gauss, just below Sir Isaac Newton, or below Sir Isaac Newton and Leibniz. Okay, so now, how did he invent zero? And why there is an importance of zero in mathematics? So when in mathematics we use 10 symbols. Oh, India also, one of the important things India also did is created decimals. So place value for whole number was created. Place value for whole number was created in Mesopotamia, and place value for decimals was created in India. So decimal. Alright, so before India, we had the idea of 1, 2, 3, 4, 5, 6, 7, 8, and 9. So there are 9 symbols, we call them symbols, we use these 9 symbols to do the mathematical calculation. All right, so this gift given to the humanity by Egyptian and Mesopotamian, the people in Egypt and the people in Iraq. Nowadays, when we talk about people in Egypt, we are talking about violence. Nowadays, we are talking about people in Iraq. We are talking about the terrorism of Islamic State. But back then, when we talk about Egypt, we are talking about pyramid. We are talking about qubit. We are talking about computing. We are talking about math. Back then, when we are talking about the Iraq, we are talking about Mesopotamian. We are talking about the cradle of civilization. We are talking about the mathematics. We are talking about the solving problem. Here's difference. Now, this was given by Egyptian and Mesopotamian. Got it? Now, Aryabhat realized that there is something missing. Everything looks all right? No. Everything doesn't look all right. Pretty soon you're going to run out of numbers. And also the inspiration comes from 10 fingers. Early humans probably had 12 fingers. That's why back then in Africa they had 12 base number system. Now this is base, it's gonna be base 10 pretty soon by adding 0 right here. Alright, so the Brahmagupta, not Brahmagupta, Aryabhat, don't confuse. Sometimes I get confused. Who did what? Brahmagupta and Aryabhat and Ramanujan. Now, Aryabhat is credited for the invention of 0. Brahmagupta is credited for differential calculus. And Ramanujan is credited for whole loss of whole body of mathematics, including power series. Okay. So Aryabhat told us that 1 plus 0 is equal to 1. This comes from Aryabhat because he invented 0. It's so easy, it's so trivial now, but it wasn't trivial back then because he, as a father of 0, had to teach us how 0 behave with other symbols, other 9 symbols. Now we have 10 symbols. So he had to teach us how 0 behaves with other 9 symbols. This is how 0 behaves, and we call it addition. How now 0 behaves with subtraction? Voila! 0 behaves with subtraction much the same way 0 behaves with addition. Now, you want to check how 0 behaves with multiplication. 0. So Aryabhat had no problem with that. 0 behaves with addition, 0 behaves with subtraction, and 0 behaves with multiplication. Now, Aryabhat couldn't figure out the next one, how 0 behaves with division. Aryabhat couldn't figure that out. In math and science, you even if you are as big as Isaac Newton, you alone cannot solve all the puzzles. You leave some of the puzzles for other people to solve. Okay? But it was solved in India that when you 0, that's how 0 behave. When you divide anything by 0, you get infinity. Alright? So this is Indian contribution. Alright? India gave us 0. And now we're gonna explore the Vedic math. The Vedic math, I'm gonna write 3 and I'm gonna write 2. 3 plus 2 is 5. So 3, 5, 2. It's a magic. It takes 1 second to do it. So how can you do that? So you write 4, you write 5, 4 plus 5 is 9, 495. It's as simple as that. Very simple. So it takes 1 second. You give me any number. I'll tell you. I don't know. 34 times 11 would be how much? You write 3. You write 4. 3 plus 4 is 7. 374. And we're gonna write 97 over here. We're gonna make a line. Okay. So how much 99 is away from 100? Negative 0.1. And how much 97 away from 100? Negative 0.3. So the Vedic Mathematics tells us this is how you do that. 97 minus 0.1 is 96. And negative 1 times negative 0.1 times negative 0.3 is just 0.3. So 96 is 0.3. Pretty simple. Let's do one more. This time I'm going to let you do it. Let's do I don't know, any number. 96 times 97. Alright, so 96, 97. Alright, so I'm going to give you a few seconds to solve it. Okay? Don't use the calculator. Use the Vedic Mathematics. So 96 is negative 0.4 away from 100. And 97 is negative 0.3 away from 100. So what are you going to do? 97 minus 4 is 93. And 3 times 4 is 12. So 9312. So I'm going to verify that because I'm not sure whether that's right or wrong. So let me verify that. Okay, I have a calculator. 9697. Nine three one two. It takes few seconds to do the mathematics, the calculation using the Vedic mathematics that invented in India. Alright, so now the final thing, the final contribution, math contribution to mankind is by India is the infinite series. Alright, so when we talk about infinite series, something is worth discussing. The geometric series was already there. So when we talk about geometric series, we actually talk about this. A x raised to n. This is the geometric series. Alright, so now how the infinite series should look like. A n x minus c raised to n, sum of n goes to 0 to n goes to infinite. Alright, so how the extension would look like? The extension would look like, so how this is different from the geometric series. Geometric is ax raised to n. Alright, so essentially in geometric series, this is the power series. In geometric series, the c is 0. And in geometric series, a is constant, a is same all the time. But here, a is different. So this is how it should look like if you extend it. So a is 0, x minus c 0, plus a1, x minus c1, and blah blah blah. Is go forever. Now I'm going to give you three example of the infinite series. Number 1, I'm going to ask you to calculate this one. 1 plus half plus 1 over 4 plus 1 over 8 plus 1 over 16. How much is that? How big is that? This is 2. This is 2. Alright, now I'm going to give you 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5 plus 1 over 6 plus 1 over 7. How big is that? This is infinity. One more. 1 square plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared plus 1 over 5 squared plus 1 over 6 squared, and so on. How big is that? So now I gave you 2 tools. The tool number 1, I told you this is 2, and tool number 2, I told you this is infinity. Now your job is to find out whether this is converging or it is diverging. This one converges to 0, this one diverges to infinity. Will it converge or will it diverge? Alright, now it's time to give you the summary. So a few days ago I started the history of mathematics to tell you that what separates us from animals. Why are we talking about animals? We are talking about animals because today is Eid. Lots of people sacrificing animals. Although I don't sacrifice animals. Okay. Anyway, what separated us from animals? Mathematics separated us from animals during the Stone Age, when we started solving math problem using Shango bones in Africa. That separated us from animals, and we gave our name Homo sapiens. Then this tradition was enriched by people in Mesopotamia. Now we call it Iraq. And then that legacy was enriched by people in Egypt. And that legacy was enriched by people in China. And then their legacy was enriched by people in India. Today we talk about 3 people. Aryabhat, who invented the concept of 0 and who also helped us understand how 0 behaves with other numbers. Number 2, Brahmagupta, who independently created differential calculus way before Leibniz and Sir Isaac Newton. Number 3, we talk about Ramanujan. We also talk about Shakuntala Devi, but in a different context. And we also talk about what India gave us, or how India helped to the world of mathematics. India created 0, number 1. That creating 0 meaning that India is credited for base 10, that what we use today. So when we talk about numeric, we are talking about Hindu-Arabic numeric, because 1, 2, 3, 4, 5, 6, 7, 8, 9, these are by Arabs, which we're going to talk about tomorrow, and 0 is by India. So that's why we call it Hindu-Arabic numeric. When we talk about Hindu-Arabic numeric, we're talking about the 10 symbol we use. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? And then what else India did? The decimals, the power series, the infinite series, the trigonometry, a whole body of mathematics. And finally we talk about the Vedic math. Alright, so I will end this conversation by solving another Vedic math problem because it's magic. And you tell me, you give me a multiplication problem, and you give me a multiplication problem, I'll solve it in 1 second. No matter how big it is, I will solve it in 1 second. That's how Shubhanu Isaac solved math problem in a fraction of a second. He used Vedic math, the trick and tools coming from Hinduism, Vedic math. Alright, let's solve this one. 32 times 11. 3, 2, 5. Boom. 1 second. This is called magic. Okay? I'll see you tomorrow.